What if we want to generalize this model to find the optimal mix for any given number of products? For example, let's replace table by product 1 and share by product 2. And we can have more products, product 3, product 4, etc. Same for resources. We don't really care about the type of the resource, but we care how many units it will be used from resource 1 to produce product 1. Same for product 2. And how many units will be used from resource 2 to produce product 1, and the same for product 2 and the same for product 3. Depends how many number of products we have. For the profit also, if I sell product 1, how many profit I will get, and how many profit from product 2 and the 3 if we have. The available carpentry time is actually the available amount that I have from the first resource. Same the available amount that I have from the second resource. This is the same for finishing. And the decision variables, it's no more table and shares. It's simply x1, which is number of products that should be produced from product 1, and x2, which is number of products that should be produced from product 2. And I can have x3, 4, 5, etc. This depends on the number of products that I'm mixing. So in this case, if we want to formulate this problem, we will start with parameters and notations. N is the first parameter, which is equal number of products. I can have 1, 2, 3, 4, up to infinity number of products. P is the vector that have the profit of each product. So it's logical to have it from 1 to n because number of products is n. So the size of the vector P is 1 to n. The first cell in product P will have the profit of the first product, where the second cell in vector P will have the value of profit from product 2 and etc. So simply it's a profit of product I. I can be 1, 2, 3, 4 up to n. The same applies in the vector R1, which is the required amount from resources 1 to produce product I. Product I is one product from the set 1 to n. It can be 1, 2, 3, 4 up to n. The same concept for R2. R2 is a vector that includes the required amount from resource 2 to produce product I, where I belongs to 1 to n. So it can be 1, 2, 3 up to n. Product 1, product 2, product 3 up to product n. AR, available resource 1. Total amount available from resource 1, same for AR2, which is total available amount from resource 2. In this case, I have defined all the constant as parameters, and I use the compact way to represent different values. I have here three vectors P, R1 and R2. Decision variables. I will define the decision variables as vector also. Why? Because I have certain number of products and I want to know how many units I should produce from each product. So I have xi, which can be x1, x2, x3, x4 up to xn. x1 belongs to number of units of products 1 to be produced, where x2 is number of units of product 2 to be produced. The objective function can be written as a summation because, as you can see here, I tried to sum the profit from the first product and the profit from the second product. So simply profit from the first product times the units that should be produced from the first product plus P2 times x2 plus P3 times x3 till Pn times xn. Constraints can also be written as a summation because here I am summing the required resources for each product. So required resources from resource 1 for product I times the number of units that will be produced from product I should be less than the available total amount of resource 1. The same for the second constraint. Required resources from resource 2 for product I times number of units that will be produced from product I. And I will be the first product, then the second product, then the third product till the summation is complete. And this should be less than the available amount of resource 2. In this way, I have wrote my optimization formulation in a compact way. So how to reflect this formulation in CPLEX? I want to keep the old formulation, so I will keep the model and I will try to create a new model in my project. So let's close the old model and go to the project tutorial product mix, because it is the same project but I am developing another model or more professional model. I will right click and new model. I need to choose the project and then give my model a name. So I will give it the same name but with version 2. Then I can add a data file also, new data file, the same name but version 2. Also I need to add run configuration, new run configuration, and this run configuration will include my version 2 model and my version 2 data file. So I will drag and drop it. Okay. By the way, I can use the first data file in my second run configuration and the model will read from the first data file. In case I am using the same data file and I did not change anything between the first model and the second model, so simply I can use the same data file in both. So it depends on your case. Now let's convert this formulation to CPLEX formulation. Let me paste my template. I have parameter annotations, decision variables, objective function, constraints, and results display. I will start defining the parameters. First, I have n, and n is integer because I cannot have 1.5 type of products. It should be either 1, 2, 3, 4, 5 types, etc. So it is integer called n and equal to, in this case, 2 products. It can be 3, 4, 5, etc. Secondly, I have a vector with size 1 up to n, in this case size 2 because n is 2, so float, p, and vector. The size of the vector, I will add it between the parentheses, 1 up to n. Why? Assume that you have a profit vector that includes your profit values from each product. So it will simply be, for example, 60 and 40. So how we represent this in CPLEX? We write that P is a vector having the size 2, 1 up to n, maybe 2, 3, 4, depends on number of products that you have, equal 60 and 20, semicolon. So it's exactly the same. I have a vector here that contains two values. These two values corresponds to two products. The first product's profit is 60, the second product profit is 20. What I only added that the name of this vector, which is p from profit, and 1 up to n, which is the size of this vector. The same will be done for the other vectors. Float r1 resource 1, I have here 1 up to n products equal 4 and 3, or any value. This depends on how many units is required from resource 1 to produce product 1, and how many units is required from resource 1 to produce the product 2. I have here a mistake, should be float. Same here, float r2, I have n number of products, so from 1 to n equal to 1, 2, and 1, and I have a float AR1, which is total amount of resource 1, total available amount of resource 1, equal to 120 or 260, float for available amount of resource 1, which is equal to 160, float available amount from resource 2, 120. So I have defined my parameters. Let's go to the decision variables, which are summarized in a vector 2. Let's go to the decision variables, which are also summarized in a vector. This vector is called x and having the size 1 up to n, because I need to decide how many units I will produce from each product, and I have n number of products. So this is a decision variable from type integer, and that's it. I defined the set of decision variables, or the vector that includes my decision variables. For the objective function, it is a maximization, so I need to use maximize. Then I have summation, and the function is summation function, so I will use sum, open parenthesis, and write sum from where to where, from I in 1 to n. So I will use I as my index, and it will be 1, then 2, then 3 up to n. And the summation function is pi times xi. So the I will take the value 1 and we will have p1 times x1, then plus the I will take value 2, p2 times x2 up to n. We'll do the same for the constraints. Subject to sum of I in 1 to n. This is my first constraint, constraint 1, and the summation function is r1i times xi should be less than or equal to total available amount of resource 1, AR1. Second constraint is also a summation. I'm using I from I equal 1 to n. Resource or unit required from resource 2 for product I times number of units from product I less than or equal available units from resource 2. So in this case, I have formulated the model using OPL language in CPLEX. And as you can see, I used here vectors to define the values of several parameters, also to define decision variables, and also we use the summation function in the objective and constraints. Let's add a script to display our results. To add a script, you should use execute, then two parentheses. Inside execute, you will write what do you want to execute after the model is run. I want to write len. Write len is a function that will display whatever written inside it. So I want to add a text, so I will use quotation mark number of units of product 1 space comma then the variable. The variable for product 1 is x1. So in this case, it will display the text number of units of product 1, then the value of the decision variable x1. I will copy, paste in a different line for product 2. I will change the text and the variable. So number of units of product 2, I am using x2, the second variable. Same I can add for product 3, etc. Or I can use a loop to consider all my products. Let's say this is enough for me now at this stage, and I want to run this model to display the results. To run this model, I need to make sure I have a configuration that have the new model. Okay, I did not use the data file yet, so it's not important, but it is recommended to have it also. So later on, if I use the data file, it will be ready, set up, and ready for use. So to run it, right click in the new configuration and run this. I got the answer 60 and 0. If I double check the values of my parameters, this is different than the previous solution because I used 20 instead of 40 for the second product. So if I corrected this one to be 40 and run the model again, I will get 50 and 20, same answer that we got in the previous model or the version 1 of this model. And also I used the script. So how to display the script? I will go to scripting log, and as you can see here, number of units of product 1 is 50, number of units of product 2 is 20. This is the text and this is the value of the variable.